be all ready when I'm done. Okay, so did you guys do the preparation stuff?
Yeah, it was basically just, going through the lesson. There wasn't an assignment.
Okay. Let's go ahead and get started with the quiz, unless anybody's got any questions.
No.
Nope.
All right, so let's start with number 2, question number 2. Did you guys answer all the questions for the? So we should be able to just go through this fairly quick.
Yeah.
So in the article, Journal of Business Management, one set of data compared educational level of people who manage successful startup companies in the US and Korea. The hypothesis test that I picked was the chi-squared.
I put down the same thing.
Yeah.
Okay, number 3. There you go.
A human resources manager reported data from a recent involuntary reduction in force. At your company, you are an attorney and want to determine if age discrimination was a factor. Is it legal to discriminate against employees because of age? The company reported the number of employees in 2 groups, 40 years old or younger and over 40 years old. They also reported the number of employees in each group who were terminated. You want to determine if both age groups were treated equally. Which hypothesis test would be most appropriate for this analysis? Would it be test of 2 proportions or independent sample test? Or either?
I did the 2 proportions.
The 2 proportions?
How about you, Dylan?
I did the independent sample t-test.
Okay, so they are, it's not quantitative. They're wanting to know if they were treated
or would it be
quantitative? Whether they were terminated or not terminated. And so when you are doing categorical, it's the proportion test. Quantitative would be the independent sample test, from my understanding.
Okay.
So because there's no numbers involved here.
Well, does the ages count as that, or does that not really?
Because those are the categories of under 40 or over 40. And then whether they were terminated or not terminated.
Oh, okay. I see what you mean.
I mean, I could be wrong, but that's my understanding.
No, I'm fine with the independent.
So it should be the
2 proportions, I mean.
Yeah.
You guys are.
All right, number 4, Dylan.
Okay, a survey was conducted by a group of state lotteries. A random sample of 2,406 adults completed the survey. A total of 248 were classified as heavy players. Of these, 152 were male. We want to determine if the proportion of male heavy lottery players is different than the proportion of males in the population, which is 48.5%. Which hypothesis test would be most appropriate for this analysis? And I think test of 1 proportion.
Yes, very good. That one's a little tricky because they mention, they're just trying to figure out males. Sometimes when you think, oh, they're trying to figure out males, then they want to know females, so you think it might be 2, but we're only looking at the male proportion.
Yeah, and if you see the word proportion in there, that's a hint that it's going to be one of the proportions.
Very good. All right, number 5. These ones I had a hard time with. So a student project compared the effectiveness of two different combination locks. One turned clockwise, the other turned counterclockwise. They asked 25 students to participate in the study. Each student was given the combination to each lock and asked to open the locks. The time it took them to open each lock was recorded. They want to determine if one of the locks is easier to open. Which hypothesis test? So this is, you're comparing two, I think they're independent samples.
Yeah.
So I would go with the independent sample t-test.
Okay, that's what I was thinking.
Okay, Cami, you're up, number 6.
Okay. For the next 3 questions, identify the one confidence interval that is most appropriate for the given situation. A bank employs 2 appraisers when approving borrowers. When approving borrowers for mortgages, it is imperative that the appraisers value the same types of properties consistently. To make sure this is the case, the bank evaluates 6 properties that both appraisers have recently valued. Which confidence interval would be most appropriate for this study? Okay. Would it be the independent again?
This one I was so confused on because it says that they need to have the same type of property. So in that respect, it means like they would have to like take one same type of property and compare it to another same type of property. So in that case, it would be the paired sample, but it doesn't make that completely clear. But I went with the paired sample, but it could be the independent sample. You want to weigh in here, Dylan?
I think it's the paired sample because
Okay.
they want the same type of property, and one type of property influences what the second type of property will be.
And that's what I chose to go as well. I wish they'd made it a little bit more clear, but we'll go with it and see how it goes.
Okay, sounds good.
All right, number 7, Dylan.
Okay, in a Wall Street Journal article on satisfaction with career paths, the percentage of psychology majors reporting they were satisfied with their career path was reported. The same data was also reported for accounting majors. We decided to construct a 95% confidence interval to see if the observed difference is significant. Which confidence interval would be most appropriate for this study?
What do you think?
Would it be an independent sample T confidence interval?
We're not dealing with numbers. We're
So it's
dividing if they're satisfied or not.
okay, then it's 2 proportions.
Right.
Okay.
This one I was a little confused on, so maybe you guys will have better. So double stuffed Oreo cookies are supposed to have twice the filling of regular. You and some friends decide you want to know if that's true. You take a sample of 55 double stuffed Oreo cookies, measure the amount of filling in each one. You need to construct a confidence interval to estimate the true mean filling amount of double stuff in order to compare it to the filling amount in regular. But they're not having us compare, they're not having us sample the regular Oreos.
Mm-hmm.
So I don't know what, so it would, we're just doing a one sample. I would just go with the one sample T confidence. But we're supposed to be comparing it to the regular Oreos, but it's not having us figure that out. Maybe we already, they assume that the regular filling is already known somehow.
Yeah, I would think one sample, two confidence interval.
Okay, now let's see. All right, Kenny.
Okay, which one of the following best defines the notion of the significance level of a hypothesis test? Okay. The probability of observing. Hold on. Isn't shoot. All these word ones always make me so confused. So significance level, isn't that, I want to say it's number 3, but I feel like it's number 2.
It's number 3. You were right.
Okay.
Because we use that to determine whether we're going to reject the hypothesis or not.
Okay, that makes sense.
Number 10, Dylan?
Okay, which one of the following best defines the notion of the p-value of a hypothesis test? I think it's number 3 on this one.
Mm-hmm.
Suppose you create a 95% confidence interval. What does this mean? This one's so dumb, but it's 95% of all 95% confidence intervals actually contain the true mean.
I've like always gotten this question wrong on every quiz, and it makes me so mad. It doesn't make any sense to me.
Well, because in the reading they never put it this way. I only know it's this one because I've gotten it wrong enough times and I've fixed it.
Yeah, me too.
Number 12.
Okay. You take a simple random sample of 100 adults from a town in the western United States to determine the proportion of those in town who invest in the stock market. Assume the unknown population proportion of or percentage of people in town who invest in the stock market is P equals 0.30 or 30%. What is the mean of the distribution of the sample proportions? Wouldn't it just be, wait. I know this is a really simple question, but would it be 30 or would it be 0.30 times 100?
It's the 0.3.
Okay.
Dylan?
Okay. What is the standard deviation of the distribution of the sample proportion? Okay. Okay, for the standard deviation, I get 0.046.
Yes, that's what I got. Okay, number 14. Do you know how we got that, Cami?
Yeah, sorry.
What is the probability your random sample of 100 adults will have the sample proportion of less than 0.25, and I got 0.138. And that's just using the normal probability applet.
Okay.
Doing everything left of the, I had to figure out the z-score in order to do that.
Mm-hmm. Okay.
What did you say you got?
0.138,
Okay.
and that's just using the sample proportion minus the population proportion divided by the standard deviation.
Okay.
Okay.
Right.
Oh man. Okay, Acupril is meant to control hypertension. In clinical trials of Acupril, 2,142 subjects were divided into two groups. The 1,563 subjects in the experimental group received Acupril. The 579 subjects in the control group received a placebo. Of the 1,563 in the experimental group, 61 experienced dizziness as a side effect. Of the control group, 15 experienced dizziness as a side effect. Let P1 be the true proportion of people who experience dizziness while taking Acupril. Let P2 be the true proportion of people who experience dizziness but do not take Acupril. Okay. So create a 95% confidence interval for P1 minus P2 and put the margin of error, lower and upper bounds below, rounded to 3 decimal places. Okay. So I haven't written down any of the formulas yet, so I can't remember exactly the formula.
I'd cheat on the margin of error. We'll see if it's right, but you just take the lower bound minus the upper bound, and then you divide that by 2, and you should have the margin of error.
But how do you get the lower bound and the upper bound?
So you go into Excel for the, what is it, the categorical data analysis of the that we can use to enter the information. You don't have to do any of these calculations. You can use Excel.
Wait, how did you get the Excel sheet? I mean, I have. Sorry, go ahead.
If you go to the lesson 20 review.
Oh, okay.
And then you pull up the summaries under lesson summaries. You put in show summaries.
Okay.
And then under lesson 17 recap, it's got that categorical data analysis .xls. I haven't used the SPSS for the proportions because Excel's so easy. And he said we can use it.
Yeah. Okay.
Did you get that pulled up?
Yeah.
So then on that one, you just enter for this is a one sample z test for proportion. So in X, you would put the number that performed better, which was the 50. And okay. The total number was 200. That goes in N. And we're doing a 0.95, and we're comparing it to the 0.2.
Okay.
Wait, is that right? I'm sorry. This is a different one.
You're fine. Is it the two proportions? The two sample t-test for proportions?
Yes.
Okay.
So let's go. I'm two proportion, and I did already put those in there. And did I do this right?
And then okay. Okay, so for the confidence interval, for the lower, did you get 0.003, and for the upper, 0.029? Sorry, I know I'm probably answering the next couple questions.
No, okay. It's negative 0.003.
Oh, yeah.
And then the 0.029. So you take the negative 0.003 minus the 0.029, and then you divide that by 2. And don't use the negative when we use the margin of error.
Okay. So did you get negative 0.013?
I got 0.016.
Oh, okay. Okay, never mind. I see what you mean. So do we use the negative or do we not use the negative? Because I used.
Yeah, don't, when you state the margin of error, you don't use the.
Oh, I see what you mean.
You just want numerical value. Are you in agreement, Dylan? You're being awfully quiet.
Sorry, I couldn't hear what you said. What did you answer it as?
0.016.
Okay. 0.0.
Is that what you got?
Yes.
All right, and then we just already answered the question of negative 0.003 for the lower bound.
Yeah, and then 0.029 for the upper bound.
Yep. You with us, Dylan?
Sorry. When did you say the upper and lower were?
The lower bound was the negative 0.003.
Okay.
And the upper was 0.029.
Okay. Okay. Yeah.
All right. I think it's your turn, Dylan, number 18.
Okay, performing a hypothesis test to see if the proportion of the experimental group subjects who experience dizziness is different than the proportion of control group. Use a level of significance of alpha equals 0.05, or the appropriate null and alternative hypothesis. Let's see. I believe it's the first one, I think.
Yep. That is correct. And then the value of your test statistic is 1.458. You can get that just off of the cell there.
Okay, and then for the p-value, I got 0.928.
Point what?
0.928. So what you guys got on the Excel?
Make sure on the type of test that it's, and on your inputs where it says type of test,
Oh, since it's
P1 does not equal P2.
Yeah. Oh. Gotcha. How do you do that in Excel? How do you write that?
Oh, there should be like a little arrow when you
I gotcha.
highlight it. So you click on that little arrow and it gives you options.
Okay, so the p-value would be 0.145.
Yes.
Okay, gotcha. Thank you.
So always make sure you have all of those boxes checked or you'll get the wrong numbers.
Okay.
All right, Dylan?
Okay. On the p-value, it was 0.928, right?
No, it was 0.145.
Okay. Just making sure.
You have to make sure that on the type of test, it's the P1 does not equal the P2.
Okay.
Okay.
Is there sufficient evidence to conclude that the true portion of people who experience dizziness while taking acupressure than the true proportion of people who experience dizziness while not taking acupill?
So our p-value is higher than the 0.05.
Oh, yes. So, no, we failed to reject the null hypothesis, the bottom one.
Correct.
Yeah.
All right. A survey was conducted of 1279 randomly selected adults, 18 and older. They were asked, are you a morning person or a night person? The hypothesis for this study is the null is that they're independent of age. Alternative is not dependent of age. The results of the survey are given. Okay, so this one you would go into the Excel sheet and you would choose the chi-square.
Yeah.
And then you'd enter those numbers for the row 1 and row 2. And the test statistic for the hypothesis test I got was 6.58 or 6.579, I guess I could put in there. 6.579 is the statistic.
Okay, that's what I got. No.
Okay, 6.79.
6.579.
Okay, 6.5.
Okay, and then the p-value is 0.0881. Yeah, 0.0866, so 0.087.
0.087 is what I got.
0.87.
Yeah, 0.087.
And then number 24.
Okay, so to reject or not to explain. Yes, the p-value is. Let's see. Yes, the p-value is greater than 0.05.
We failed to reject if it's greater.
Yes.
So what's the question?
Oh, wait, no.
Should you reject? No.
No, the p is greater than.
Right.
So it's
So confused when they get to the words. It's so confusing.
I don't know, it's like they're trying to trick you every question.
We failed to reject because it's greater. So that's a no. P-value is greater than 0.05.
Okay.
What do you conclude based on your results? So I put the last one. We have insufficient evidence to say that being a morning or evening person is not dependent on age.
Yeah, I got that too.
Dependent of age, I should say.
Okay. A recent book noted, are you guys all good on question 25?
Yeah.
Okay.
Yeah.
A recent book noted that only 20% of all investment managers outperform the Dow Jones Industrial Average over a 5-year period. A random sample of 200 investment managers that graduated from one of the top 10 business programs in the country were followed over a 5-year period. 50 of these outperformed the Dow Jones Industrial Average. Let P be the true portion of investment managers who graduated from one of the top 10 business programs who outperformed the Dow Jones over a 5-year period. So based on the results of the sample, create a 95% confidence interval of P, and put the lower and upper bounds below, rounded to 3 decimals.
So this on the Excel, we would use the 1 proportion.
Okay.
And you have to make sure that you put in the 0.2, where it says null hypothesis, because that's what we're comparing it to.
Okay.
And then which type of test would we be doing?
It doesn't say if they want it to be greater than or less than, so would it just be not equal to?
No, it says we're trying to figure out if, let's see, random sample. 50 of these outperformed the Dow Jones Industrial. Let P be the true proportion of investment who gradually who outperformed. So that tells us we want to see if they did better than. So greater than. Because we're seeing if, see, you have to look for those words. So we wanted to see if they outperform.
Okay. So did you get negative 0.0? Oh, just kidding. We're just doing the lower bound and upper bound. So lower bound, did you get 0.190?
Yes. And then, Dylan, did you know how to do this in Excel?
No, I do not have Excel.
Are you doing it in XPSS?
Hmm?
Are you doing these in SPSS?
No, I've had to do them the old-fashioned way.
Oh. Okay. So do you have the number 27, or do you want me to just tell you what to do?
I think it would be quicker if you did it.
Who's having a party?
Oh, do you hear lots of voices?
Yeah.
Sorry, I'm in the crossroads at the school. There's
That's okay.
people around.
I just have a party here with my kids keep coming in. So I apologize for that. That's
How
my
many
party.
How many kids do you have again?
I have 5.
Oh, how old is the oldest and how old is the youngest?
So my oldest is 15 and a half. And then my daughter is 6. So,
Oh, that's awesome.
yeah, she just started school this last year, so I'll be going to nursing school in the fall.
Oh, sweet. That's so cool.
Busy, busy. All right. So did you figure these out, Dylan?
Just give me a minute.
It's okay if you didn't. I have the upper bound.
Okay, what was it?
It's 0.310.
Okay.
And you could do number 28. But you have to do that the old-fashioned way. Do you guys have the formula for that one?
Number 28.
Yeah, number 28.
I haven't made my note card yet. I don't have all the Only is written down yet.
I just started. I was doing that this morning. So you're up on this one, Dylan. Do you have the formula?
Yes.
Okay. Cami, how are your wedding plans coming?
They're good. I think they have almost everything planned. I have a really big family on my dad's side, and so I'm just having all of them make cookies and brownies, and that's pretty much what I'm going to do for my reception.
Where are you getting married?
Seattle Temple.
Fun.
Yeah,
And
it's going to be exciting.
when is the wedding?
July 29th, so in about a month.
So the semester will be over by then, right?
Yeah.
You don't have to do homework on your honeymoon?
Oh my days, that would be horrible.
Do you know where you're going on your honeymoon?
Yeah, do you know the San Juan Islands up in Washington?
Yeah.
They're like in the Puget Sound. Yeah, so we rented like a little cabin for a couple of days on the San Juan Islands.
Yeah. And then do you start school back in August then?
Yeah.
So you'll both be living there in Rexburg?
Yeah.
So exciting.
I know.
Get your dress up?
Yeah, it's ordered. It's just still, the dress shop is still getting it because they don't have my size, so they're rushing it or making that order or something. So it should be here any day.
Did you get it there in Rexburg?
Yeah.
That's good.
Mm-hmm.
So when do you head home?
Head home for the wedding.
Well, is your family in Seattle?
Most of my family's in Seattle. I actually live in Oregon, but yeah, all my family lives there.
So will you go home before the wedding?
Just a couple days before. We already have our apartment set up, and he wants to stay here for his birthday, which is a couple days before the wedding. So we'll just stay here, and I'll stay at our apartment, and you'll stay at home. And then, yeah.
All right. Sorry, Dylan. Did you get that figured out?
Yes. I got 1,536.64.
Okay. Then you have to round it up to the 1537 because you can't sample a percentage of a person. So that would be 1537. I seem so bossy. I'm sorry, I'm always bossy.
You're fine.
No, it's all right.
Keep us in mind.
All right. Suppose you wish to see if there is evidence that graduates of one of the top 10 business programs performs better than other investment managers. Conduct a hypothesis test. Use the level of significance of 0.05. So performing better is going to be the greater than. So the P equals 0.2, and the alternative is P is greater than 0.02. So it's the 1, 2, 3, 4, fifth one down.
Okay, that's what I got. Okay, and then for question 30, what requirements must be met to ensure that P hat is normally distributed? So I just did the first one.
Right.
Yeah.
And Dylan, number 31.
Okay. Now you have the test statistic.
Poor Dylan, we're giving him all the ones they have to use a formula on.
I know. And he doesn't have the easy way to plug it in.
I know.
Do you not have the Excel,
Nope.
Dylan?
Only had SPS because they said that was the one that was occurred.
Okay. I think you can do this on SPSS. I just haven't tried it on there.
I don't know. Oh, here was the screen. Yeah. I miss this place. So I think I miss it. Are you still in North Point? You know what you got?
Do you have the formula?
Yes, I think the test statistically says sit over n. Wait. Let's see. I get 0.25 if I'm right, if I did this right.
That's not what I got. Well, that's not what the Excel got. Right?
Okay, what did Excel
So, 1.768.
Yeah, that's what I got too.
So let's make sure you have the right formula, which the Z for the proportion is Z equals P hat minus P divided by the square root of
Yeah, I was looking at the
P.
wrong one.
Okay. P times 1 minus P. So just make sure for your test you write down all the right proportions.
Yeah.
On the review, if you go to click on the summaries, it has all the calculations or all the formulas. And he said that a good portion of it was going to be from the first two exams. I hate when they do that because I've already forgotten all that.
I know, me too.
We all have.
So it's what the test statistic is 1.768.
Yeah.
And the p-value is the 0.039.
Yep. Okay. Is there sufficient evidence to conclude that graduates from the top 10 business programs perform better than other investment managers? So it's a low, so we reject the null. So yes, I rejected the first one.
Yes, that's what I got. Okay, so now we are needing the SPSS. We're getting into older stuff here. So you guys pull that up if you don't already have it pulled up.
Okay, I got it pulled up.
You guys got that pulled up?
Yeah.
How about you, Dylan?
We're waiting for it to come up.
had to pull out, try and remember what to do for these. Because it was like several weeks ago.
I know.
Did you figure these ones out, or are we going to do it right now?
He's gonna do it right now. Sorry, I was just moving my laptop. It's dying.
Oh, you're... Is Dylan? Did yours come up yet?
Yes, but for some yes, but for some reason it closed right afterwards.
Oh shoot!
Because there was some sort of hiccup in the system or something.
All right. Well, I'm going to just start talking. So on this one, which test do you think we're supposed to perform? Because it doesn't tell us. So we have to figure it out.
Sorry, every outlet I'm finding is not working. It's not charging my laptop.
It's okay. Hey, Millie, did you take my phone? Bring it here, please. Right here. Millie, please don't take my phone. Not for a little while. I was just going to text you and say that I'm going to have to go tomorrow. Clean. And you and Grace are on the kitchen today, so I need you to put away dishes. Okay. No, you need to go make sure that your room is clean. Did the dogs get fed? Go ask the other kids if they didn't feed the dogs. I want you to feed them and give Libby her medicine. Okay? And then clean your room. My kids want to watch a show.
So Dylan, did you get it pulled up?
Yes.
Okay, so what kind of test do you think we're going to perform on this?
Is it just a one sample? One sample t-test?
Yes.
Okay.
We don't know this. Sigma is unknown, so that always suggests a t-test.
Mm-hmm.
And we have just the sample, or the one sample.
I was always I was always a little confused. What do you put in the test value box when you're doing it on SPSS?
So we are comparing it to the 0.295.
Okay, that's right. Okay.
Whatever they give us for the sample mean or the population mean or whatever, that's what we put in for the test value.
Okay.
Okay.
Okay, so whose turn was it?
I think it's Dylan's.
Okay. After inputting that in, my lower bound was negative 0.013.
Yes, that's what I got. Negative 0.3.
Yeah, that's what I got too.
And the upper bound is negative 0.002.
Yeah, that's what I got. Okay, calculate the degrees of freedom, the test statistic, and the p-value for a test of the null is equal to 0.295. Against the alternative where it's not equal, assume the requirements are satisfied, and put your answers. So the degrees of freedom, is that just 99?
Yeah.
Yes.
And 37.
Input the test statistic. Let's see. The test statistic is t, which is negative 2.803.
Okay. And the p-value is 0.006. Wait a second. Are we hold on, I want to make sure I got this right. We are H is not equal, so let's make sure we have that right. No, we have to do, two-tailed. Okay, yeah, that's right. That's 0.006.
Yeah, that's what I got.
And then,
Okay. Based on the results of this test, what would you conclude? Use the level of significance of 0.05. So I said we have insufficient evidence to say that the true mean is equal to 0.295. So the second one.
we never want to refer to the null hypothesis.
Okay, so we'll redo the first one, that we have sufficient evidence to say that the true mean is different than that.
Yes.
Okay.
Because we can never, from what I remember, we can never prove that the null hypothesis is true or not. We can just only prove that there's evidence to suggest that the alternative hypothesis could be true.
That makes sense.
Right. Now we're doing the AM/PM heights. So Dylan, what type of test are we going to perform on this one?
Let's see. Find the differences in. Let's see. Let's see. A paired sample t-test, I think.
Right. Paired sample. And I don't know about you, but I think they made us, when we were doing this, they made us do the, calculate the difference and then run one sample. But I just found that if you go into the analyze and compare means, you could just run a paired sample t-test.
I found that a while back too.
Did you discover that as well, Cami?
Sorry, what was that?
So when they had us go through the process, they were having us, add that. We go into transform and
Oh, yeah.
all that sort of stuff. I found that we didn't need to do that. I don't know why, because I don't know why they made us do it that way. It's the long way. But if you go into the analyze and compare means, and then you just go down to the paired samples t-test.
Yeah. That's what I found too. I just did that the shorter way too.
That's how I do it. So
And it's crazy. I don't know if I don't remember if I told you guys yet or not, but like my fiance is in business stats, and it's
Yeah.
the exact same course, and they give them all the data and everything in Excel, and then they've had those Excel sheets for every single set of data that they have, and I was like, that's so much nicer.
I know. Making us, and business is where I think you would use this more than in the biostatistics.
I know, right?
Someone's just going to give us the statistics. We don't have to figure out how to get there. All right. So I can't remember whose turn it is.
I
I think it's Dylan.
Yeah, I think it's Dylan too.
Okay, after performing the paired t-test, I got the lower bound as 8.728.
Yeah, that's what I got too.
8.728. Okay. And the upper bound is 10.455.
Yep. Okay. Input the test statistic for this test. So the test statistic. Did you get to 22.446?
Yes.
It seems really high.
Where is it? 22, yeah, 22.446.
Okay.
So you can pretty much guarantee that we will. Okay, so the degrees of freedom is 40. And Dylan, wait, sorry, did I go out of turn?
Uh,
I can't remember.
yeah, but it's fine. So Dylan can just take this
Dylan,
one.
you did the p-value?
Yes. I got zero on that one.
Yeah.
Okay, and then I have the next one. 1 second. So since we rejected the null, so yes, we rejected the null.
Yes.
Yay, we're done.
And we're done. Okay, well, let's see how we did. I feel okay about everything except those first questions where we have to figure out which test to use. Those look the hardest for me.
Okay, so we missed 4 total.
Okay, so let's see which one we missed here.
So question 34 and 35 we got wrong in the lower and upper bounds.
All right, and we got the number 5 wrong. Independent sample test.
And number 9 wrong. Wait. It's all those word ones. They're so confusing.
Check to open the lock was recorded. They want to determine if one locks is easier to open. All right, so let's go to number 5 here. I mean, if you want to go back over them.
Sure.
So this one is the locks. Number 5 was the 2 different combination locks. Each has been in the county so last second. The time that took them to open each lock was recorded. So that's quantitative.
Yes.
And there's 2 different ones. So it's either independent or paired sample.
What was ANOVA again?
The ANOVA is if there's more than
3, that's right. But how would it be paired? Because the one of them doesn't affect the other. It's just 2 different.
That's what I'm saying. And I don't think it's a proportion test because we're dealing with quantitative. So dumb. I honestly don't.
Or would it be qualitative because it says they want to determine if one of the locks is easier to open.
I know, but they're doing that by recording the time
Yeah.
that it took.
I'm not sure.
And they're not giving us.
It's confusing.
What'd you say, Dylan?
I don't think this one is quantitative because at the end they say they want to determine if one of the locks is easier to open.
Well, I guess we could try the 2 proportion for that one. All right, I'm going back through and hold on. Now we have to. I hate this. You have to input everything again.
Yeah, I know.
All right, why don't we just. So let's try the 2. I'm going to do the 2 proportion for that.
Okay.
Okay, and then. Done? Okay, don't ask me until you've done all those things. Okay, so then number 9. Ugh, it's another one of those dumb ones. Which one's my best? The notion of, oh.
Oh, wait. Did we figure out number 5?
Yeah, I was just going to put in the 2 proportion.
Okay.
That's the other one I could think that it would be because there's examples.
If you look at it, it says they asked 25 students to participate in the study.
Yeah.
Each student was given the combination to each lock and asked to open the locks.
Oh, you're right. It is a paired sample.
Okay. Sorry, I didn't see that earlier.
Because yeah, you're right. Good catch. And then number 9 is the.
I still think it's probability of the type 1 error.
But it could be the probability. All right, well, I don't think it's. Okay.
This is not even needed at the alpha level.
Okay. So.
And then the next one we got wrong was.
It was 34 and 35. Which I don't understand how we got that wrong.
Unless we performed the wrong test on it.
But we got everything else right on it.
Okay, so let's look at that one again. This one. Um, .013, negative 0.013, and negative 0.002.
Ooh. I just did it again and oh wait, no, I got the same ones. Yeah, I'm not sure.
All right. I'm not sure I care enough to redo this.
I am on the same boat.
All right. Well, if you guys want to figure that one out on your own, otherwise I don't care enough right now.
That is totally fine with me.
What is it?
I don't know how it would be different than that.
Yeah,
I mean,
I'm not sure either.
we figured that out wrong. All right, I'm good to go here.
Okay.
That's not going to let me do
Sorry
this.
for taking so long.
Oh, no, it's okay. No, we're good. All right, so those are only, oh, we did have to talk about something really quick. Oh, now let me check something really quick.
Oh yeah,
Yeah, because we have to do our data collection.
yes.
I need to see if he responds, because I don't know if he responds to everybody's, but on mine he he responded to me that we needed to change a few things.
Okay.
And so
here.
So he did that for you guys too?
Yes.
I have no idea where.
Okay, so
It is in the grade book.
In the grade book?
Yes, where it says my grades.
okay, so I resubmitted it, but I haven't heard back from him.
Okay.
I'm gonna send it. I'll send him an email just to make sure that he sees that I resubmitted it. So I resubmitted it as, let me pull it up really quick so I can tell you. I'm sorry, but I just made some executive decisions.
Hi, how are you?
Good, how are you?
Good. How have you been?
Good.
Good.
Are you doing homework?
Yeah.
Always something.
Exciting.
Alright, what are you studying again?
Math education.
Okay.
Yeah. Sorry, this is Kit. This is
Hello. And you're gay?
yeah.
When you getting married?
Next month, actually, July 29th.
Congrats.
Thanks.
So he said that
Well, see you later.
we needed to change some things up with the sampling method and so forth.
Oh yeah, I see now where he replied to it.
And so instead of just doing 30 different products, I thought we would just pick 30 different cereals and just compare cereal prices.
Okay.
So
Sounds
you
like
might want to write this down. But we can't start anything until he sends us the information. So, so the sampling method that I decided on was the systematic sampling. So we'll go into the cereal aisle and we'll start from the third package, and I'll just email this to you. So
Okay.
with the third package on the top row, starting from the left. So wherever the cereal aisle is where you are, you'll start from the left-hand side, top row, pick the third package, pick the price, and then you'll do every seventh package after that, moving from left to right, and then you'll move down to the next row and until you have 30. That makes sense?
Okay. Yeah, that makes sense.
I'll email it to you.
Okay.
And then, but I'll email him just to make sure he saw that I resubmitted. And then as soon as I get that as soon as I see that he approved it, then we'll go ahead and go do that.
Okay, I hope he does it
Right?
soon. Yeah, because I'm leaving to go out of town on Friday.
So am I. So I will let him know that. So.
Okay, sounds good.
And if we don't hear from him, let's just do it anyway, and hopefully it'll be okay. But
Sounds good with me.
I will send an email right now, and
Okay.
And then we should be good. And then I'll email yes or no that we got approved, and then I'll tell you, I'll do that sampling method that I just put in there.
Okay.
That work for you, Dylan?
Yes.
Okay. Well, have a good day and good luck on the exam.
Thanks,
And
you too.
You too.
All right, see you guys Thursday.